November 6, 1943. Imperial Japanese Navy Headquarters, Tokyo. Commander Hideo Yano, newly appointed Chief of Naval Intelligence's 5th Section, studies reconnaissance photographs spread across his desk. The images, taken by a Mitsubishi C-5M reconnaissance aircraft 3 days earlier near the Gilbert Islands, show something that makes his practiced eye narrow with concern. An American aircraft carrier, designation unknown, displacement approximately 30,000 tons. But it's the details visible even in these grainy photographs that trouble him most. Rows of anti-aircraft guns line both sides of the flight deck, 16 visible 40mm quad mounts, more than double the defensive armament of Japan's fleet carriers. The vessel's island superstructure rises compact and purposeful from the starboard side. And there, barely visible in the photograph's margin, another carrier of identical design steaming in formation 2,000 yards astern. 2 carriers, built to the same pattern, operating together as if mass-produced. Yano reaches for his intelligence summary from the previous month. American carrier designations confirmed in intercepted communications. Essex, Yorktown, Lexington. 3 separate vessels. 3 identical silhouettes. The names themselves tell a story. Yorktown and Lexington were carriers sunk in 1942. The Americans are not just replacing losses. They are replacing them with improved designs faster than Japan can construct anything. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. He opens a folder marked Most Secret, containing translations from American newspapers acquired through neutral Sweden. The New York Times, dated September 20th, 1943, includes a brief notice about naval commissioning ceremonies. USS Bunker Hill commissioned May 25th. USS Intrepid expected. Completion, September 16th. Essex-class fleet carriers. The American press labels them openly. No deception, no secrecy, as if the enemy sees no strategic advantage in concealing production capabilities. Yano calculates dates in his notebook. USS Essex commissioned December 31st, 1942. USS Lexington, the replacement Lexington, commissioned February 17th, 1943. USS Yorktown commissioned April 15th. USS Bunker Hill commissioned May 25th. 4 fleet carriers in 5 months. He stares at the numbers. Japan's carrier construction program, accelerated after Midway, projects completion of Unryu by August 1944. 1 carrier in 2 years. The mathematics refuse to align with doctrine. Japanese naval planning had assumed American industrial capacity could produce perhaps 2 fleet carriers annually, maybe 3, with extraordinary effort. But 4 in 5 months suggests a production system operating at scales Japanese intelligence had not predicted. Worse, it suggests the 4 photographed and reported carriers represent merely initial production. If American shipyards can build 4 carriers in 5 months, they can build 12 in 15 months, 20 in 25 months. He pulls another document from the intelligence file, a report from Captain Toshihiko Imai, stationed at the embassy in Mexico City before diplomatic relations severed. Imai had subscribed to Jane's fighting ships and every American aviation magazine available through neutral channels. His final report, transmitted in November 1941, detailed American shipbuilding capacity. 4 major Navy yards: Newport News, Brooklyn, Norfolk, Philadelphia. Combined slipway capacity: 16 simultaneous major warship constructions. Imai's report had been filed and largely ignored. Pearl Harbor's success had suggested American naval power could be crippled through decisive attack. Midway's disaster had proven otherwise. Now, 16 months after Midway, Yano understands Imai had been right. The Americans possess not just the will to rebuild, but the industrial infrastructure to do so at production rates Japan cannot match. A knock interrupts his analysis. Lieutenant Shima, his assistant, enters with additional reconnaissance photographs, these from submarine I-19, which had surfaced briefly south of Hawaii to periscope observation range of Pearl Harbor's approaches. The submarine's commander, exercising considerable risk, had photographed what appeared to be a newly arrived carrier task force. 3 Essex-class carriers, visible in formation, escorting cruisers and destroyers in numbers that suggested the Americans were no longer husbanding naval assets. They were deploying them freely, confident that losses could be replaced. "Commander," Shima says quietly, the submarine also observed drydock activity. They counted 5 additional carrier-sized hulls under construction or repair within the harbour's protected waters. At least 2 appeared to be new construction, not battle damage repair. Yano thanks him and adds the information to his growing file. 8 carriers visible or reported in Pacific waters, 5 more under construction. 13 carriers. Japan, at this moment in November 1943, operates 6 fleet carriers, including the damaged Zuikaku undergoing repairs. 6 carriers facing 13, with more American hulls launching every month. He examines the submarine's photographs more carefully. The detail surpasses the aerial reconnaissance images. One photograph captures an Essex-class carrier at anchor, taken from perhaps 3,000 yards range. The image quality allows Yano to count individual gun mounts. 4 twin 5-inch gun turrets visible, 8 mounts total, assuming symmetrical arrangement. Another 4 single 5-inch mounts interspersed. 17 quad 40mm Bofors mounts now visible in the clearer image. 60 20mm Oerlikon cannons. The defensive armament alone surpasses many Japanese light cruisers. But it's the flight deck that draws his attention. The deck appears unarmoured, a vulnerability Japanese carriers had addressed with Taiho's armoured flight deck. But Taiho would not enter service until spring 1944, and even then, the armoured deck's weight would reduce aircraft capacity. The Americans had chosen differently. Unarmoured deck, maximum aircraft capacity. Overwhelming anti-aircraft firepower to protect the vulnerable deck. 2 different philosophies. Japanese carriers built as precision instruments, American carriers built as weapons platforms, designed to overwhelm defences through sheer volume of aircraft and defensive fire. Yano pulls Jane's Fighting Ships, 1941 edition, from his shelf. The entry for American carrier construction lists Essex-class specifications. Displacement, 27,000 tons standard, 31,000 tons full load. Dimensions, 872 feet length, 147 feet beam. Flight deck length, 850 feet. Machinery, 8 boilers, 4 Westinghouse turbines generating 150,000 shaft horsepower. Maximum speed, 33 knots. Aircraft complement, 90 to 100 aircraft. 100 aircraft. Yano compares this to Shokaku, Japan's finest fleet carrier. Shokaku carries 72 aircraft maximum. The Americans have designed carriers that embark 1/3 more aircraft. Not through larger displacement, Shokaku displaces 32,000 tons, actually heavier than Essex, but through more efficient internal arrangement. American carriers dedicate more internal volume to hangar space and less to armoured protection. Another philosophical difference: Japan builds carriers to survive hits. America builds carriers to avoid hits through overwhelming fighter protection and destroy enemies before they can attack. The phone rings. Admiral Koshiro Oikawa, commander of the Naval General Staff, requests his presence for an intelligence briefing in 1 hour. Yano gathers his photographs, production estimates, and comparative analyses. He knows what questions will be asked. How many carriers do the Americans have? How many are they building? Can Japan match their production? The answers exist in his files. The answers are not encouraging. He walks through the corridors of naval headquarters, passing bulletin boards displaying war news. Glorious victories in the Solomons, the bulletins proclaim. American forces repelled with heavy losses. But Yano has read the classified battle damage reports. Japanese carriers Hyo and Junyo damaged at Santa Cruz. Zuikaku requiring months of repairs. American carriers Enterprise damaged but returned to service within weeks. Repair capabilities matter as much as construction capabilities. The Americans have both. In Admiral Oikawa's office, 6 senior officers wait. Yano recognizes faces. Admiral Nagano, Chief of Naval General Staff. Admiral Shimada, Navy Minister. Admiral Toyota, Commander of Combined Fleet. The leadership that must plan operations with forces being steadily outnumbered. He spreads his reconnaissance photographs across the conference table. Essex-class carriers, he begins. American designation for a new fleet carrier class entering service in large numbers. Intelligence has confirmed at least 8 units operational as of November 1st, 1943. Photographic evidence suggests an additional 5 under construction at American Navy yards. Admiral Nagano studies the photographs. Construction rate? 3 to 4 carriers per month based on commissioning dates observed, Yano answers. We believe American shipyards have prioritized carrier construction following losses at Coral Sea and Midway. The commissioning interval between USS Essex in December 1942 and USS Intrepid in September 1943 spans 9 months with 7 carriers launched. Assuming this rate continues, American carrier strength will reach 15 to 18 units by mid-1944. The room falls silent. Admiral Shimada speaks carefully. Our intelligence prior to Midway estimated American carrier construction capacity at 2 units annually. These numbers suggest our estimates were incorrect by a factor of at least 6. Yano nods. Our pre-war intelligence focused on capital ship construction. Battleships, heavy cruisers. We accurately assessed American battleship construction based on visible slipway activity and published launching ceremonies. However, carrier construction occurs largely within covered building ways. External observation cannot assess internal progress. We undercounted work in progress by assuming American yards would maintain pre-war construction tempos. Admiral Toyota leans forward. You're saying American yards accelerated production schedules after Pearl Harbor? Yano spreads additional documents. Construction time for USS Essex. From keel laying in April 1941 to commissioning December 1942, totaled 20 months. Construction time for USS Yorktown. Keel laid December 1941, commissioned April 1943, totaled 16 months. They have reduced construction time by 4 months through process improvements. He pauses. Recent intelligence from neutral sources indicates USS Lexington, commissioned February 1943, completed construction in 14 months. They are optimizing faster than we are adapting. Admiral Nagano asks the question Yano dreads answering. Can Japanese shipyards match this production rate? Yano chooses his words carefully. Japan's carrier construction from Pearl Harbor through November 1943. 1 fleet carrier, Taiho, expected completion spring 1944. 2 years construction time. Light carriers Ryuho and converted carriers Junyo and Hyo already in service but smaller than fleet carriers. New construction programs authorized for Unryu-class fleet carriers, with Unryu expected completion August 1944, 3 years after keel laying began. He meets their eyes. American Essex-class construction time has decreased from 20 months to 14 months. Japanese Unryu-class construction time remains at 36 months. We cannot match their construction rate. We cannot reduce our construction time significantly because our yards lack the prefabrication facilities and standardized components that allow American rapid assembly. Each Japanese carrier remains individually constructed with custom-fitted components. American carriers use interchangeable parts manufactured to standard specifications. The implications settle over the room like morning fog. Admiral Shimada breaks the silence. You're saying the Americans have industrialized carrier construction. They build carriers the way they build automobiles, in factories with assembly, lines and interchangeable components. Yes, sir, Yano confirms. And their automobile industry produces 3 million vehicles annually. They have applied automotive mass production principles to warship construction. Our intelligence indicates American shipyard workers include significant numbers of women, relatively unskilled laborers trained to specific assembly tasks. Japanese shipyards rely on master craftsmen whose skills require years to develop. We cannot rapidly expand our skilled workforce. The Americans can train new workers in months and assign them standardized assembly tasks. Admiral Toyota asks, what about carrier quality? If Americans are mass-producing carriers with unskilled labor, surely the vessels must be inferior to Japanese construction. Yano anticipated this question. He pulls out technical analysis reports. Our pilots have engaged Essex-class carriers 3 times. Battle of Tarawa, November 20th. Our aircraft achieved surprise attack against USS Independence and USS Essex. USS Independence sustained torpedo damage but remained operational. USS Essex sustained no hits, despite multiple attack waves. Battle damage assessment suggests Essex-class carriers possess extensive watertight compartmentation and damage control systems that allow them to sustain significant hits while maintaining operational capability. He continues, interchanged reports suggest Essex-class carriers embark damage control teams of over 100 personnel trained specifically for firefighting and hull breach repairs. Compare this to Japanese carriers, which rely on general crew for damage control. The Americans have professionalized every aspect of carrier operations, including survival after battle damage. Admiral Nagano rises and walks to the window overlooking Tokyo Harbor. Can we alter our production strategy? Build smaller, faster carriers? Sacrifice capability for quantity? Yano has anticipated this question too. He references another document. Light carrier conversion programs could potentially increase Japanese carrier numbers. However, converting merchant hulls or cruiser hulls to light carriers requires 8 to 12 months per conversion. Essex-class construction now requires 14 months and produces a much more capable vessel. We would spend nearly equivalent time producing inferior vessels. The meeting concludes with instructions to continue monitoring American carrier production and to brief combined fleet intelligence weekly on observed capabilities. Yano gathers his documents and returns to his office. The afternoon sun angles through the windows, illuminating dust motes and casting everything in amber light. He thinks about the reconnaissance photographs, the production schedules, the uncomfortable mathematics of industrial warfare. Japan entered the war believing fighting spirit and superior training could overcome material disadvantage. The calculus worked when American carriers numbered 6 and Japanese carriers numbered 11. Midway reduced Japanese carriers to 4 fleet units, while American carriers remained at 3. But Midway was 16 months ago. Now American carriers number 13, with another arriving monthly. By mid-1944, the Americans will operate 18 to 20 carriers against Japan's projected 8. By year's end, 25 American carriers against perhaps 10 Japanese units. The mathematics become starker. Each Essex-class carrier embarks 100 aircraft, 25 carriers embarking 2,500 aircraft. Japan's current aircraft production averages 700 aircraft monthly across all types. Fighters, bombers, reconnaissance planes. The Americans could lose every aircraft aboard 25 carriers and replace them within 4 months. Japan loses 700 aircraft and requires 1 month to replace them if pilot losses don't constrain operations first. Yano pulls out a classified report on pilot training programs. Japanese naval aviators require 2 years of training before reaching carrier operational status. Advanced maneuvers, night operations, dive bombing, torpedo attack, each skill perfected through repetition. The system produces exceptional pilots, but exceptional pilots die. Midway lost 110 naval aviators, including many veterans with years of experience. Santa Cruz lost 148 aircrew. These men cannot be replaced. Not in 2 years. Not in 5 years. American pilot training, according to captured documents recovered from downed pilots, requires 18 months from initial training to carrier qualification. The Americans reduced training time by 30% through standardized instruction methods. They produce competent pilots rather than exceptional pilots, but competent pilots flying 100 aircraft per carrier overwhelm exceptional pilots flying 70 aircraft per carrier through sheer numbers. He recalls a phrase from the American Civil War he'd read as a student studying at Harvard before the war. General Ulysses Grant had described Union strategy: find out where your enemy is, get at him as soon as you can, strike him as hard as you can, and keep moving on. The Americans were applying industrial warfare doctrines perfected through their Civil War, refined through 2 world wars. Find the enemy, strike with overwhelming force, continue producing faster than the enemy can replace losses. Japan's strategy required a different approach. Avoid decisive battle, extend the war, make American victory so costly that negotiated settlement becomes preferable to continued sacrifice. But that strategy assumed rough parity in carrier numbers, or at least a stable American carrier force that could be attrited faster than replaced. Neither assumption remained valid in November 1943. Evening comes. Office staff depart for the day. Yano remains at his desk, writing a supplementary analysis requested by Admiral Oikawa. The Admiral wants projections. Carrier numbers in 6 months, 1 year, 18 months. The analysis requires assumptions about American production rates, Japanese construction completion schedules, and combat attrition rates for both sides. Yano begins with observed data. 8 American Essex-class carriers operational November 1943. Average commissioning rate, 1 carrier every 30 to 40 days. Projected American carrier strength by May 1944, 13 to 15 Essex-class units. By November 1944, 20 to 22 units. By May 1945, 28 to 30 units. Japanese carrier strength is harder to project. Current operational fleet carriers: Shokaku, Zuikaku, Junyo, Hyo, Ryuho, 5 units. Taiho completes spring 1944. Unryu completes August 1944. Additional Unryu-class carriers scheduled through 1945, but dependent on material availability and shipyard capacity. Optimistic projection: 10 Japanese fleet and light carriers operational by November 1944. Combat attrition remains speculative. American carriers prove difficult to sink, none lost since Hornet at Santa Cruz in October 1942. 13 months without carrier losses despite intensive operations suggests American defensive capabilities make carrier sinking exceptionally difficult. Japanese carriers prove more vulnerable. Shoho sunk Coral Sea. 3 carriers lost midway. Damaged carriers requiring extensive repairs remove units from operations for months. The attrition ratio favors America even without accounting for production. Americans replace carriers faster than Japan can sink them. Japan cannot replace carriers faster than America might sink them if American forces achieve air superiority. The strategic calculus admits only one conclusion: time favors America. Every month that passes increases American carrier superiority. Every battle attrites irreplaceable Japanese pilots, while American pilots, though less experienced individually, arrive in steady streams from expanded training programs. Yano completes his analysis and places it in the classified file. The conclusions will not change operational decisions. Admiral Yamamoto is dead, killed when American fighters intercepted his inspection tour aircraft in April. Admiral Koga commands Combined Fleet now, but Koga inherited Yamamoto's strategy. Seek decisive battle, destroy American carriers, force negotiated settlement. The strategy made sense in 1941. In November 1943, with 13 American carriers operational and more arriving monthly, decisive battle means sailing Japanese carriers into combat against numerically superior forces with better training replacement systems. He thinks about Commander Imai's pre-war intelligence reports, filed away and forgotten. Imai had understood American industrial capacity. He had counted the shipyards, measured the slipways, calculated potential production rates. His warnings had been dismissed as pessimistic, misunderstanding Japanese fighting spirit's capacity to overcome material disadvantage. Now, 2 years into war, Yano sees Imai had been optimistic. American production exceeds even Imai's calculations. The office grows dark. Yano closes his files and prepares to leave. Tomorrow brings another briefing. Another week of reconnaissance photographs showing more Essex-class carriers in more Pacific anchorages. The intelligence will be compiled, analysed, reported up the chain. Decisions will be made by men who must balance mathematical reality against institutional doctrines developed when carrier forces were equal and victory seemed achievable. Walking home through Tokyo streets, Yano passes air defense posters urging vigilance. The home islands remain beyond American air attack range. B-17 bombers based in the Marianas could not reach Tokyo, but Essex-class carriers operating near the Marianas could launch strikes against Saipan, Tinian, Guam. American carrier task forces could position within 500 miles of Japan and launch strikes against the home islands. The carriers that make such operations possible are being launched every 30 days in American shipyards 7,000 miles away. He reaches his home and lights the desk lamp in his study. His son's photograph sits on the desk, taken before the boy shipped out to Rabaul as a naval air mechanic. The boy maintains 0 fighters, keeps them flying, services aircraft that defend against American bomber raids. Yano wonders if his son understands what the reconnaissance photographs show. Probably not. The mechanics see individual aircraft, individual carriers. They don't see the production systems launching carriers every 30 days. That night, Yano dreams of shipyards, massive covered ways where carrier hulls take shape. Workers, thousands of them, assembling prefabricated sections like children's building blocks. Hulls, growing with mechanical precision, standardized components fitting together without custom adjustment. Carriers launching every month because the system has been perfected, optimized, made proof against individual error through systematic redundancy. He wakes before dawn and returns to headquarters. More reconnaissance photographs await, more production estimates to compile, more intelligence summaries projecting American carrier strength 6 months forward, 12 months forward. The mathematics never change. American production accelerates. Japanese production remains constrained by skilled labor shortages and limited shipyard capacity. By mid-1944, the intelligence summaries will prove accurate. Essex-class carriers will number 18 units operational in Pacific waters. They will form the core of Task Force 58, the fast carrier task force that will strike Truk, assault the Marianas, engage Japanese carriers at Philippine Sea. Admiral Ozawa's mobile fleet, 9 carriers with 400 aircraft, will face 15 American carriers with over 900 aircraft. The Battle of the Philippine Sea will prove what Yano's intelligence summaries predicted. Numerical superiority, when combined with adequate training and defensive systems, overwhelms individual excellence, but that battle lies 7 months in the future. In November 1943, Yano compiles intelligence and writes reports and watches reconnaissance photographs accumulate. Each photograph shows another Essex-class carrier. Each intelligence summary projects another month forward. Each analysis concludes the same thing. American industrial capacity has created a carrier force Japan cannot match through construction and cannot defeat through combat attrition. The war will continue another 21 months after November 1943. More Essex-class carriers will join the Pacific Fleet. More battles will demonstrate American material superiority. More intelligence reports will document the undeniable. Japan entered a war against an opponent whose industrial capacity made victory mathematically impossible once the initial surprise attack failed to eliminate American carrier power permanently. Commander Yano will survive the war and participate in post-surrender negotiations. American naval officers will ask him about Japanese intelligence assessments. He will share his reconnaissance photographs, his production analyses, his uncomfortable conclusions reached in November 1943. The American officers will be surprised. They did not realize Japanese intelligence had understood American production capabilities so early. They will ask why Japan continued fighting when intelligence revealed inevitable defeat. Yano will have no good answer. Or rather, he will have the only answer that matters, because institutions built on doctrines of fighting spirit cannot acknowledge that fighting spirit proves insufficient against industrial systems designed to produce carriers faster than opponents can sink them. Because admitting defeat requires destroying the institution that must admit defeat, because sometimes societies choose to continue fighting not because victory is possible, but because surrender is unthinkable. June 19, 1944, Philippine Sea, west of the Mariana Islands. Vice Admiral Jisaburo Ozawa stands on the bridge of carrier Taiho, flagship of the mobile fleet. Through his binoculars, he scans the eastern horizon where American Task Force 58 operates somewhere beyond visual range. His fleet represents Japan's last concentrated carrier striking force. 9 carriers embarking 430 aircraft. Intelligence reports suggest the Americans have 15 carriers in the area with over 900 aircraft. The mathematics trouble Ozawa less than they should. Japanese doctrine emphasizes quality over quantity. His pilots, though less experienced than the veterans lost at Midway and in the Solomons, have trained for this decisive battle. His aircraft possess longer range than American counterparts, allowing strikes from distances beyond American retaliation. Land-based aircraft from Guam and Rota will supplement carrier strikes. The plan requires coordination, timing, and fighting spirit, all attainable objectives. At 0830 hours, the first wave launches. 69 aircraft, 0 fighters, Judy dive bombers, Jill torpedo bombers. They climb to altitude and turn east toward the reported American position 160 miles distant. The second wave follows at 056, 128 aircraft. Third wave at 1000 hours, 47 aircraft. Fourth wave at 1100 hours, 82 aircraft. 326 aircraft committed to strikes against an enemy whose exact position remains uncertain. Ozawa does not know that American radar detected his aircraft the moment they achieved altitude. He does not know that American fighter directors aboard Essex-class carriers are vectoring Hellcat fighters to intercept positions calculated through radar plot S. He does not know that American Combat Air Patrol doctrine stations fighters in layered defensive zones, specifically designed to destroy incoming strikes before they reach the carriers. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. At 10:36 hours, the first wave encounters American fighters 50 miles from Task Force 58, F-6F Hellcats from USS Essex, USS Lexington, USS Enterprise intercept at 20,000 feet. The Japanese formation dissolves under coordinated attacks. 0 fighters, excellent in turning combat, prove vulnerable to the Hellcats' superior speed and diving attacks. American pilots employ tactics perfected through 2 years of combat, boom and zoom attacks that exploit the Hellcats' 600 horsepower advantage. Within 15 minutes, 42 Japanese aircraft are destroyed. 27 survivors continue toward the American task force. They penetrate the outer fighter screen and encounter the gun line. Battleships and cruisers positioned forward of the carriers, their 5-inch guns firing proximity-fused shells that detonate near aircraft without requiring direct hits. The shells create lethal fragmentation patterns that damage or destroy aircraft in 3-dimensional kill zones. 16 more Japanese aircraft fall to anti-aircraft fire. 11 aircraft reach attack positions against the carriers. They face a defensive curtain unlike anything Japanese aviators have encountered. 17 quad 40mm Bofors mounts per carrier, each mount firing 160 rounds per minute. 60 20mm Oerlikon cannons adding 6,000 rounds per minute to the defensive fire. The mathematical volume of metal in the air makes successful attack runs nearly impossible. One Judy dive bomber achieves a near miss against USS South Dakota. The bomb detonates close enough to damage radar equipment but fails to penetrate the battleship's armored belt. No other attacks succeed. 10 Japanese aircraft are destroyed attempting attack runs. One limps away toward Guam with battle damage. The second wave fares worse. 128 aircraft launched. 97 destroyed by fighters and anti-aircraft fire before reaching attack positions. 31 surviving aircraft attack. 0 hits. 24 more aircraft destroyed during attack runs. 7 survivors return toward their carriers. Ozawa receives fragmentary reports. Heavy enemy fighter opposition. Anti-aircraft fire extremely intense. Unable to locate carriers. The reports suggest significant American defenses but provide no accurate damage. Assessment. Japanese doctrine assumes that aircraft reaching attack positions achieved hits. Pilots report seeing explosions, smoke, ships maneuvering. These observations, filtered through combat stress and optimistic interpretation, become reports of carriers damaged or sunk. At 1300 hours, Ozawa believes he has damaged or sunk at least 2 American carriers. The belief shapes his decisions. He maintains his position, preparing additional strikes. The fourth wave launches at 1100 hours encounters the same defensive system that destroyed the previous waves. Of 82 aircraft launched, 73 are destroyed, 9 return. By 1400 hours, the battle's first day concludes. Japanese aircraft losses. 315 carrier aircraft destroyed. Approximately 50 land-based aircraft from Guam destroyed when they attempted to land and refuel during American strikes against the island's airfields. 365 aircraft lost from an initial force of 430 carrier aircraft, and TAL, 300 land-based aircraft. American aircraft losses: 23 aircraft destroyed in combat, 6 pilots killed. Ozawa does not yet know these numbers. He knows his aircraft have not returned. He assumes they landed at Guam or Rota, refueled, and will return tomorrow. He does not know that American submarines have been stalking his fleet. At 12:20 hours, USS Albacore fired torpedoes at Taiho. 1 torpedo struck the carrier's starboard side. Initial damage appeared manageable. Damage control teams reported flooding contained. But Taiho carried unrefined Tarakan petroleum as fuel. The crude oil's volatile naphtha fraction vaporized, filling compartments with explosive fumes. At 14:32 hours, a spark ignited the accumulated fumes. The explosion tore through Taiho's interior, destroying bulkheads, igniting fires, rupturing fuel lines. The carrier's modern damage control systems, designed to handle battle damage, proved inadequate against internal explosions, propagating through volatile fuel vapors. At 16:28 hours, Taiho sank. Ozawa transferred his flag to cruiser Haguro and attempted to assess his situation. Fragmentary reports suggested heavy American carrier damage. His own carrier losses: Taiho sunk. Shokaku, torpedoed by USS Kavala, sank at 15 hours after progressive flooding overwhelmed damage control efforts. 2 fleet carriers lost. 7 carriers remained operational, but most had recovered only fragments of their original air groups. That evening, Ozawa calculated his remaining strength: approximately 100 aircraft operational across 7 carriers. Intelligence estimates suggested American strength remained substantial despite the day's combat. The decisive battle he had sought had occurred. The result did not match expectations. He ordered withdrawal northwest toward Okinawa. The following day, June 20th, American carrier aircraft located the retreating Japanese fleet at 1600 hours. The range exceeded standard strike distance. Launching attacks meant recovering aircraft after dark, a dangerous operation. Admiral Mark Mitcher, commanding Task Force 58 from Carrier Lexington, ordered the strike anyway. 216 aircraft launched at 1630 hours. At 1800 hours, American aircraft found Ozawa's fleet. Attacks concentrated on carrier Hio. Multiple torpedo and bomb hits overwhelmed the carrier's damage control. Hio sank at 2000 hours. Additional attacks damaged carriers Zuikaku, Junyo, and Chiyoda. Oilers, Genyo Maru, and Seio Maru were sunk. 80 American aircraft were lost during the return flight. Most ran out of fuel and ditched near the task force. Destroyers rescued most pilots. The tactical loss, 80 aircraft, was severe. The strategic outcome was decisive. Japanese carrier air power had been destroyed. Of 430 carrier aircraft that began the battle, fewer than 35 returned to carriers. The mobile fleet retained 7 carriers but lacked aircraft or pilots to operate them effectively. In Tokyo, Commander Yano received battle reports through June 21st. The initial reports suggested victory. American carriers damaged. Japanese fleet withdrawing after successful engagement. But subsequent reports arriving through June 22nd and 23rd painted different pictures. Taiho lost, Shokaku lost, Hio lost, aircraft losses exceeding 300 units, pilot casualties approaching 400. Yano compiled the data and compared it to his November 1943 projections. He had estimated American carrier strength at 15 units by June 1944. Task Force 58 composition confirmed 15 carriers, 7 Essex-class, 5 Independence-class light carriers, 3 Enterprise and other fleet carriers. His projection had been accurate. He had estimated American aircraft strength at approximately 1,000 carrier aircraft. Actual strength, approximately 950 aircraft. Again, accurate within 10%. His projections for Japanese strength had also proven accurate. 9 carriers operational with approximately 400 aircraft, but his analysis had not predicted the combat outcome's severity. He had calculated that numerical superiority would favor Americans, but assumed Japanese pilot quality would partially offset the disadvantage. The battle results suggested pilot quality provided minimal advantage against radar-directed fighters, proximity-fused anti-aircraft shells, and overwhelming defensive firepower. He drafted a supplementary intelligence assessment. The Battle of the Philippine Sea demonstrated conclusively that American carrier task forces possess defensive capabilities that make successful attack extremely difficult. Japanese aircraft losses approached 75%. American losses approximated 3%. This 25-to-1 loss ratio suggests systematic American advantages in radar-directed fighter interception, anti-aircraft fire control, and damage control procedures. More significantly, American carrier production continues unabated. Intelligence estimates 15 Essex-class carriers operational June 1944. Projected American strength November 1944. 22 Essex-class carriers plus light carriers and surviving pre-war fleet carriers. Total, approximately 30 fleet and light carriers. Japanese strength, November 1944, 7 operational carriers with insufficient aircraft or pilots to fully equip them. The strategic implication is unavoidable. Japan cannot replace carrier aircraft or pilots at rates sufficient to contest American carrier operations. Each battle attrites irreplaceable Japanese air groups, while American losses are replaced within weeks through systematic training programs and aircraft production that exceeds combat losses by factors of 10 or more. Yano submitted his report through proper channels. It disappeared into the same bureaucratic void that had absorbed his November 1943 analyses. But this time, the conclusions were harder to ignore. The mobile fleet still existed. 7 carriers remained, but they operated without air groups. Carriers without aircraft are floating targets, not strike platforms. In August 1944, intelligence confirmed another Essex-class carrier commissioned, USS Bonhomme Richard. In September, USS Randolph. October, USS Shangri-La. 3 more carriers joining a fleet that had already demonstrated overwhelming superiority in June. By October, Task Force 38, the fast carrier task force operating under Admiral Halsey, numbered 17 fleet carriers and escorts. Yano watched reconnaissance photographs accumulate. Each photograph showed more Essex-class carriers. Each intelligence summary documented another commissioning ceremony. Each analysis reached the same conclusion. American production capacity had created a naval force Japan could not defeat through combat and could not match through construction. October 1944 brought the Battle of Leyte Gulf. Japanese carriers operated as decoys, sailing north to draw American carriers away from Leyte, while Japanese surface forces attacked the invasion fleet. The strategy acknowledged reality. Carriers without aircraft could serve only as bait. Admiral Ozawa's northern force included 4 carriers: Zuikaku, Zuiho, Chitose, Chiyoda. Total embarked aircraft, 116. Task Force 38 attacked with over 1,000 carrier aircraft. All 4 Japanese carriers were sunk. Zuikaku, last surviving carrier from the Pearl Harbor attack, sank after multiple bomb and torpedo hits. The irony was not lost on Japanese intelligence officers. Zuikaku had helped sink USS Lexington at Coral Sea and damaged USS Enterprise at Santa Cruz. Now, Zuikaku fell to aircraft from the new Lexington and new Enterprise, replacement carriers built faster than Japan could have imagined in 1941. After Leyte Gulf, Japan's carrier force ceased to exist as an operational entity. Individual carriers survived. Amagi and Katsuragi were completed in 1944, but they operated without aircraft, without fuel, without trained pilots. They remained in port, immobilized by American submarine blockade that prevented oil shipments from the Dutch East Indies. Yano continued compiling intelligence summaries through early 1945. Essex-class carrier production showed no signs of slowing. USS Boxer commissioned April 19, 45. USS Antietam commissioned January 45. USS Lake Champlain commissioned June 3, 45. The commissioning dates no longer mattered strategically. The war's outcome had been determined by production decisions made in 1940 through 42, when American shipyards laid down hulls that would become Essex-class carriers in 43 and 44. In March 1945, Task Force 58 struck the Japanese home islands. Carriers approached to within 200 miles of Tokyo and launched strikes against airfields, factories, ports. Japanese defenders destroyed a few attacking aircraft, but the raids continued daily because American carriers could sustain operations indefinitely through underway replenishment, rotating air groups, and systematic damage repair that kept carriers operational despite battle damage. USS Franklin suffered catastrophic damage, March 19th, when a Japanese aircraft penetrated defensive screens and dropped 2 armor-piercing bombs that detonated in the hangar deck. The explosions killed 724 crew and wounded 265. The carrier suffered fires, secondary explosions from armed aircraft, and structural damage that should have required abandoning ship. But Franklin's captain refused abandonment orders. Damage control teams fought fires, contained flooding, repaired damaged systems. Franklin returned to Pearl Harbor under her own power and eventually reached the United States for full repairs. Yano included Franklin's survival in his intelligence assessments. The carrier sustained damage that would have sunk Japanese carriers. Essex-class construction standards, compartmentation, damage control training, and firefighting equipment allowed survival after catastrophic hits. The philosophical difference between Japanese and American carrier design had become evident. Japanese carriers emphasized offensive power and armor protection. American carriers emphasized damage control and sustained operations. August 6, 1945 brought news of Hiroshima. August 9th brought Nagasaki. August 15th brought surrender. Yano survived the war and participated in post-surrender technical exchanges. American naval officers interviewed Japanese intelligence personnel, seeking to understand what the Japanese had known about American capabilities and when they had known it. Yano shared his reconnaissance photographs. Images of Essex-class carriers dating to November 1943, he shared his production analyses. Estimates that had accurately predicted American carrier strength months before battle engagements. He shared his assessments, concluding Japanese production could not match American output. The American officers were surprised. "You knew?" one asked. "You understood American production capacity this early?" Yano answered carefully. Intelligence provided the data. Leadership made strategic decisions based on many factors beyond intelligence assessments. Fighting spirit, national honor, institutional doctrine, all influenced decisions. Intelligence could document American carrier production. Intelligence could calculate force ratios. Intelligence could predict battle outcomes based on numerical advantages. But intelligence could not make strategic decisions. The American officer asked why Japan continued fighting when intelligence revealed inevitable defeat. Yano had no simple answer. He explained that institutions built on doctrines of fighting spirit and decisive battle could not easily pivot to doctrines acknowledging material inferiority. He explained that admitting defeat required destroying the institution, making the admission. He explained that sometimes societies continue fighting not because victory is possible, but because surrender contradicts everything the society believes about itself. The American officers documented Yano's intelligence files. Photographs, production analyses, battle assessments all went into post-war historical records. The documentation revealed that Japanese intelligence had understood American industrial capacity remarkably accurately. The failure had not been intelligence collection or analysis. The failure had been translating accurate intelligence into strategic decisions that acknowledged reality. Years later, historians studying the Pacific War would examine Yano's files. They would see reconnaissance photographs from November 1943 showing Essex-class carriers. They would read production estimates accurately predicting 15 carriers by June 1944. They would study battle assessments, concluding American numerical superiority made Japanese victory impossible. The historical record would show that Japan's defeat stemmed not from intelligence failures, but from strategic choices made despite accurate intelligence. American industrial capacity had been visible to anyone who looked. Production statistics appeared in American newspapers. Shipyard capacity could be calculated from published data. Essex-class construction times shortened from 20 months to 14 months through process improvements visible to neutral observers. Japanese intelligence officers had compiled the data. They had reached correct conclusions. They had reported assessments to leadership. But institutional inertia, strategic doctrine, and cultural factors prevented those assessments from altering fundamental strategies. Japan continued seeking decisive battle even after intelligence revealed that decisive battle would only accelerate defeat. The Essex-class carriers that Commander Yano photographed in November 1943 continued serving for decades. USS Essex decommissioned in 1969. USS Lexington served as training carrier until 1991. USS Yorktown became a museum ship in Charleston, South Carolina. USS Intrepid became a museum in New York City. USS Hornet became a museum in Alameda, California. These museum ships allow visitors to walk flight decks where American pilots launched strikes against Japanese positions. They can descend into hangar decks where aircraft were maintained and armed. They can see damage control stations, firefighting equipment, compartmentation that allowed carriers to survive catastrophic damage. They can understand, viscerally, what Japanese intelligence officers understood intellectually in 1943. American carriers were not superior through better design or advanced technology. They were superior through systematic mass production of adequately designed vessels, built in quantities that overwhelmed any opponent. The story that began with Commander Yano studying reconnaissance photographs in November 1943 ended decades later with Essex-class carriers preserved as museums. The carriers that Japanese intelligence identified as threats in 43 became the instruments of Japanese defeat in 44 and 45. They served through the Korean War, the Cuban Missile Crisis, and Vietnam. They represented American industrial capacity, translated into naval power through systematic production methods that Japanese intelligence understood. But Japanese industry could not match. In manufacturing engineering courses, the Essex-class production program serves as case study in industrial mobilization. Students learn how American shipyards reduced construction time from 20 months to 14 months through standardized components, prefabrication, and systematic assembly processes. They learn how 5 shipyards built 24 carriers by dividing production into specialized steps performed by relatively unskilled workers trained to specific tasks. The contrast with Japanese production illustrates fundamental differences in industrial philosophy. Japanese yards relied on master craftsmen whose skills required years to develop. Each carrier represented individual construction with custom-fitted components. American yards used precision tooling and standardized parts that allowed rapid construction with less skilled workers. Japanese methods produced excellent individual ships. American methods produced adequate ships in overwhelming numbers. The lesson extends beyond shipbuilding. Modern industrial competitions, whether semiconductors, automobiles, or consumer electronics, reward systematic production over individual craftsmanship. Quality must be built into processes, not added through skilled workers' individual efforts. Standardization enables mass production. Mass production enables competitive pricing. Competitive pricing enables market dominance. Japan's post-war economic recovery applied lessons learned from studying American production methods during the war. Japanese engineers who had examined American equipment and documented American processes became architects of Japan's industrial transformation. They understood that matching American industrial capacity required adopting American production systems, not copying American products. By the 1970s, Japanese manufacturers had not only adopted American mass production techniques but refined them. Toyota's just-in-time manufacturing reduced inventory costs. Japanese quality control methods improved production. Consistency. Japanese automation increased productivity while maintaining quality. The craftsmen remained valued, but their role changed from building individual products to designing production systems that enabled consistent quality at scale. The transformation was complete by the 1980s. Japanese automobiles competed effectively with American products. Japanese electronics dominated consumer markets. Japanese manufacturing methods were studied by American engineers seeking to understand how Japan had achieved such remarkable industrial success. The irony was profound. In 1943, Commander Yano had photographed Essex-class carriers and understood that American production capacity made Japanese victory impossible. 40 years later, American manufacturers photographed Japanese production lines and understood that Japanese quality and efficiency made American dominance unsustainable without fundamental changes. The Essex-class carriers that symbolized American industrial supremacy in 1944 became artifacts in museums by the 1990s. But the lessons they taught about systematic production, standardized components, quality built into processes rather than added by craftsmen, those lessons continued shaping global manufacturing into the 21st century. Commander Yano's reconnaissance photographs from November 1943 remain archived in historical collections. Grainy images showing Essex-class carriers in formation, rows of anti-aircraft guns visible along flight deck edges, island superstructures rising compact and functional. To Yano, examining those photographs in 1943, they represented an impossible challenge. To historians examining them today, they represent a lesson about industrial capacity, systematic production, and the mathematics of material warfare. The mathematics that troubled Yano in 1943 remain relevant today. Modern military planners study production, capacity, replacement rates, and industrial mobilization potential. They understand what Yano understood, that wars between industrial powers are won by production systems, not by individual weapons platforms. That fighting spirit and tactical excellence cannot overcome sustained material disadvantage. That intelligence can identify threats, but only strategic decisions can address them. The Essex-class carriers photographed by Japanese reconnaissance aircraft in 1943 became instruments of Japanese defeat by 1945. But they also became teachers, demonstrating principles of industrial warfare that shaped manufacturing and military planning for generations. The reconnaissance photographs that revealed American strength to Japanese intelligence in 1943 became historical documents teaching lessons about production, standardization, and the industrial foundations of military power. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.